Okay, so today we're going to talk about, basically what was in the reading for you. Again, as I said in the first chapter, the front matter that talks about computers and hardware and stuff like that. It can be useful just as background information. You're not really responsible for it, but understanding how Java is configured and what its structure is important. Java naming conventions, so the way things are named is something that is important in all of what you do, whether it's in Java or some other language. It's just that each language has its own conventions. And understanding the Java compiler versus the Java virtual machine. So those are kind of two terms that, after reading, you should maybe understand it, but we'll go over that. And then object-oriented programming, which is really one of the main takeaways from this course. Part of it is becoming comfortable with the Java language, which is still the predominant one. Computing is a fairly fluid place, and other languages are always kind of coming up. As I mentioned, Python is really big with the data scientists. As a language for doing the kinds of things, at least that I do and many of my colleagues do, Java is actually preferable, but that's just another story. Okay, so in this class, I want you to understand Java's basic structure, know the different elements of a Java class, and maybe know what the heck a Java class is, and the rules and conventions for Java identifiers. Now, one of the nice things about having an IDE like NetBeans is it will gently help you with things that are just completely off, but it won't help you with the conventions, and we'll kind of get that. And then another kind of conceptual thing that will hopefully become a little bit more clear as we go along is the difference between an object and a class. Coming from JavaScript, JavaScript, unfortunately, blurs, does not have a concept of a class. And so in JavaScript, there's simply just objects. The JavaScript object model, well, in my opinion, it leaves a lot to be desired, but that's sort of another story. We're talking about Java here, not JavaScript. Okay, so what is a Java program? It consists of one or more classes. So the class is the basic unit of a Java program. So, and as we'll see, the orientation for Java is typically to have many different classes. In the beginning, of course, you just have one or maybe a handful, but in programs that I write, I will literally have hundreds of classes, and that's not a bad thing, that's a good thing. Now, coming from in Java, things like JavaScript or even Python to one extent, the orientation is toward having a whole bunch of stuff in one file. Okay, so if you're used to that, then that's something you're going to have to shift your mind a little bit on. Okay, so classes are really the basic building block of a Java program. A class consists of one or more methods, as well as instance variables. So those are the two elements of a class. Now, drilling down into methods, each method consists of Java statements. A method can have 0 or more arguments. Now, since you've used other programming languages, you should be comfortable at least with the idea of a function having arguments or not. Notice that I'm not using the term function. In object-oriented programming, there are no functions, there are only methods. So, at this point, the distinction might be a little bit vague, so don't worry about that. As we go along, that'll become hopefully more clear. Now, just as with functions, every method, it will either return a value or if it doesn't return a value, it returns something called void. And void is basically, as the name implies, nothing. One of the things that you might have to be getting used to if you're used to things like JavaScript or Python, is that every Java method must be explicit about what it returns. It has to explicitly do it, which is why this void thing is. So if a method doesn't return anything, you can't just leave it empty. You have to say void. Now, in terms of, okay, so we have all these different classes. And again, that's a mindset you might have to start to get used to. So how does the Java virtual machine know where to start? It starts with a main method. Okay, so an application has one class, and that class has a method called main, and main is the keyword for that, and that's where things start. So we'll see how that goes. So hello world, of course, is kind of where things start. This is the one that I have in the video and that I've posted to my GitLab. So let's just sort of dissect this a little bit. Okay, first of all, and this is something that unfortunately the book is not as good as it should be. In this class, in this course, every class must be in a named package. Again, that is not something which is enforced, but that is something which is it is just a terrible style to have a class that is not in a named package. Okay, what this is something called a Javadoc comment. What distinguishes it is a slash followed by 2 stars ending with a star and a single slash. There are two other kinds of comments. There are the kind with a double slash and one with just a single star. But just kind of, come on. But this is the preferred one. And so in this course, all Javadoc comments are going to be required for classes and for methods. Okay, so here's the name of the class. Now, notice, and this is one of the nice things that NetBeans does, notice that the keywords are in blue. So public class, and then the name of the class. The scope of the class is defined. Notice that there are these little yellow things in the brackets. The scope of the class is defined by these brackets. Now, that's something that you probably should be used to from JavaScript. Okay, so here's the members that every application has a main method. This is what it is. The main method must have this signature. That is, it must be public, static, void, main, and then its arguments are a string array. Now we're not going to cover arrays explicitly for a while, but we're going to be kind of using them in kind of a look forward type of thing. So you can have a method called main that is not public, static, and void, or has a different set of arguments, and that will not constitute the main method. This is what the main method is. And you may be wondering, okay, what's with all this public, and what's with this static, what's with this void? Okay, you should know what void is. Void means that it doesn't return anything. Okay, and then here's the one executable statement. So to parse this, okay, this is one of the differences between a method and a function. So system out is an object. So that's an object. So the dots are a little bit misleading, because system.out is an object. That's just sort of one thing. But when you invoke a method, you use the dot thing. And I think you should have seen that in your other languages. So print line is a method in this system out object. Okay, now in NetBeans, the output kind of goes to the console here. So when you run this, it's got a bunch of stuff here. Notice that it actually kind of runs this thing called Ant. That's why when you create a project, you create a project using Ant, despite the other options. And then here's the output. Okay, circling back to the comment, there were 3 types of comments. So there was only one kind in that, the Javadoc comment. So one is the double slash. So everything to the right of the single line is a comment there. The star slash, everything between the star slash and another star slash is a comment, and that can span multiple lines. And then star double slash is the Javadoc comment. So, all classes and methods must have a Javadoc comment, as we had here. So here was one here. Now for the main method, NetBeans actually creates a Javadoc comment for you. And in the case of the main, you don't really have to do anything unless there's something very particular about the method that you need to identify. And just as a note, the text is not so good about this. If you look at the text comments, they tend to be of these 2, and they tend to not have the Javadoc comments. I wish they had had more emphasis on the Javadoc comments. There was a very good reason for that. The Javadoc comments will create you can generate HTML pages that document what your code is about, and that will list everything in those Javadoc comments. So that's why they're important. The other 2 do not appear in the HTML pages that are generated. And again, as as I'm talking, if you have a question, feel free to just jump right in. Because especially in this mode, I'm not, if you're raising your hand or something like that, I'm not seeing it. So, all right, identifiers. Now, this is something you've been, like Mrs. Malaprop, who'd been using prose all her life, not realizing it. You've been using identifiers in the programming that you've been doing. They're the words that are in the program. So, and there are, in each language, there are rules about these, about what can and can't be an identifier. So a Java identifier, it can be letters, digits, and underscores, and $signs. However, identifiers cannot begin with a digit. So the other thing is that it's case sensitive. So here, notice that total with a capital T, total all lowercase and total all uppercase. Those are 3 different identifiers. You can have all 3 in the same class. Now, that is not recommended, by the way. Just because you can do something doesn't mean that you should do something. So even though you could do this, you could have all 3 of these in the same class, it would be really bad style. Now, every language has conventions about these, where the language itself is typically more liberal about what can be used, but there are conventions, and they are slightly different in each language. What I encourage very strongly is that whatever language you're programming in, use the idioms, the conventions for that language. So here are some of the Java naming conventions. So in the class, for a class, it uses what's called camel case, and it's capitalized. In other words, it starts with a capital letter, and you use camel case to kind of make it a little more readable. Now, for methods, they use camel case with the first letter being lowercase. So we saw main already, that. And if you had a method that had a slightly longer name, again, it would be camel case, but you start with a lowercase letter. Now, the language itself will allow you to use an uppercase. This is a perfectly legal method. Java will not complain, but your instructor will. Oops. Okay, so this is, don't do that. Okay, now packages, as we've seen, everything must be in a package. The convention for that is lowercase. Again, it's not going to prevent you from using an uppercase, but your instructor will complain. Now, instance variables, and actually this is also, there are three kinds of variables. We'll kind of get into that at some point. There are instance variables, local variables, and static variables. So this is also true for local variables. What's the difference? We'll get into that. But again, camel case, the first letter lowercase. So for example, here, this is a valid, or at least a valid following conventions. This with a capital is not. That is not. Again, Java will let you do that, but your instructor won't. However, there are things. Java does not have the concept of a constant. So what it does is it actually has things called static variables. And the convention on those is that they are static and final. Again, we'll circle back to all of this, but two examples that are actually in Java itself is pi, which is an approximation of the value of pi. Notice all uppercase, that's fine. And max value, that's something which certain numerical objects have as a constant. So the idea is that now, instead of camel case to make things sort of readable, they use underscores to make them readable. Okay, as a check, which of the following are valid? So, okay, grade, yes. Quiz grade, yes. Okay, now this is valid, but does not follow the convention. So this is technically valid, but I'll complain if I see something like that. Well, if used as a variable. However, if that's used as the name of a class, so a class name, then it follows the convention. Okay, frame 2, that's fine. Now here, this is a problem because you're not allowed to start with a number. Okay, this is valid, but ideally this should be a static final. Likewise, this underscore is fine. This is not okay because of the $, and then here the ampersand is not legal, so this is not okay. Okay, so as a check, I got it right, yay. Okay, Java has some reserved words, and here they are. I expect them all to be memorized by tomorrow. That's okay, you don't have to do that. Again, NetBeans will help you with this in the sense that the reserved words are a thing. You cannot define any of your stuff using any of these words. And these are all things that the Java compiler needs to use to identify what the heck you're trying to do with your program. So you cannot name a variable called else, for example. Okay. Now, actually, just as well, this is kind of more historical. One of the brilliant, Java was actually the first language to explicitly disallow the go-to statement. This is something that people were fussing about, a long time ago, when I was just starting out. But and language, the go-to could produce spaghetti, so-called spaghetti code. It's just kind of going all over the place. Java said that was a bad idea, and so what it did is it disallowed it by defining the word go-to as a keyword and then giving it no functionality. So you're not allowed to use the word go-to, and it doesn't do anything. Okay, so white space. Now, if you're used to Python, in Python, white space is meaningful syntactically. That is a disaster in my view. That is one of the things that makes Python sort of terrible, really. In Java, white space is basically nothing. So white space consists of spaces, blank lines, and tabs. You need at least some white space to separate the words and symbols in a program. That's something you've been doing. Extra white space just gets ignored. Again, Python is much fussier about this. Now, there are different ways of formatting in a Java program that, so it's like, where do the curly braces go? Do the curly braces go, so like this? Or do they go like this? And there have been all kinds of flame wars over, those are the two basic ones. The principle is what is readable. These are both readable. The NetBeans default is this one. This is the one I usually use. If you prefer this one, there is a setting in NetBeans that you can have all of your classes formatted this way. And if you prefer that, that's absolutely fine. The criterion is when you look at it, is it clear about what it's doing? Both of these work perfectly fine. The idea is that the formatting should enhance readability and use consistent indentation. And NetBeans has a wonderful feature called where you can just, if things kind of get all screwy, you just kind of do a format. That's something that I will, well, once I start doing some code in class, I'll show you how to do that. But that's, again, just with a couple of clicks, you can make your program look very nice. And so I expect you to do that. Okay, so now the thing about programming languages is that understand that each CPU has its own particular machine language. So if you have an Intel chip or an AMD chip, or with these new Apple chips, they have their own machine language that talks to them. And so that regardless of what platform you're using, every program has to ultimately be translated into machine language so it can be executed. So what in the early days, you literally wrote things in the machine language. Then they realized that that wasn't an ideal kind of thing, so they came up with assembler languages, and then even that turned out to be kind of problematic, and so they developed more high-level languages. So what the compiler does is the compiler takes the source code that you write, and they translate it into a specific target language. So languages like C and Fortran and the like would turn things directly into executable code that is machine language code. So what Java did was, and the problem with that is that is that a language would only typically run on one particular type of computer. So one of the things that Java came along and said, okay, we want their phrase was write once, run everywhere. So with the same source code, you can run regardless of what platform you're on. Now, these days, that has kind of become more or less ubiquitous with different languages. So for example, an interpreted language like Python runs on all languages because the interpreter takes the source code and interprets it. That's why it's a little bit slower. But what Java did was it said, okay, instead of compiling to machine language, we're going to compile to an intermediate representation called bytecode. And it's not a machine language. So that's why you need this additional thing called the Java Virtual Machine, or JVM. And so the thing is that Java bytecodes are kind of a lingua franca for Java, at least. It's not tied to any particular machine. And for each platform, there has to be a Java virtual machine that will take those bytecodes and turn those into executable. So here's this, the Java source code that you write. The compiler turns them into bytecodes, and then the Java virtual machine turns them into executable codes. And the thing is that you don't have to worry too much about this, because a lot of this is kind of hidden by NetBeans. Now, sometimes when things go a little bit wonky, then it can be helpful to just understand that's what's going on. And just, the thing about now, the interesting thing about Java before is that Java was originally developed by a company called Sun Microsystems. They were originally a hardware company, and they had a program language called Oak that they had developed internally as to write their stuff, because they were unhappy with the different object-oriented languages that were out there, most notably C++. And so what they did was they had this internal language called Oak, and then when people got wind of it, they decided it was a really cool thing. So Sun decided to try to market it. And the problem was that Oak was already a trademark name of something else. And so what would happen is the developers would sometimes meet in a local coffee shop to kind of brainstorm about what this new language should be called. And eventually somebody came up with the wonderful idea that they should call it Java. So the thing about Java is that, well, what is Java? Well, Java is actually an Indonesian island that has the distinction of being the world's most populous island. So that's one thing that Java is. And the other is that Java, of course, is, darn you, Zoom is just a pain in the butt about this. Okay, so the other is that one of the things that Java produces is coffee. So Java is also known as a synonym for coffee. So that's just the whole Java thing, and they've made an industry, at least in a while, of having little coffee-like plays on words for this. So that's kind of why Java is Java. Okay, so now what supports the development of Java? So we have what we typically need. Actually, the Java development kit is all you truly need. When I first started programming in Java, my IDE consisted of Notepad and the DOS prompt. So, however, these days you want an IDE. So the two predominant open source IDEs are Eclipse and NetBeans, and people have religious wars over which one is better. In my view, they're both equally fine. I use NetBeans because that's what I'm used to. If I'd been using Eclipse, I would be perfectly happy with that. There is nothing you can do in Eclipse that you can't do in NetBeans. There is nothing you can do in NetBeans that you can't do in Eclipse. They mentioned some of these other ones, BlueJay, JGrass. Actually, there's one called Intellij that's actually pretty good, but it's a commercial one. So the details are a little bit different, but these days, using an IDE is pretty much, if you don't, then you're just kind of setting yourselves up for a lot of agony. Okay, syntax and semantics. So the syntax are how you put together symbols, and semantics are kind of what it means. So there are kind of two steps to this. One is that the Java compiler is the one that determines whether a program is syntactically correct. So syntactically correct just means that everything is logically in place. There are no grammar mistakes, as it were. It's actually much even fussier than Grammarly, if you've ever seen that. I'm not a big fan of Grammarly, but the thing to realize is that just because a program is syntactically correct does not mean it's logically correct. So the computer programs are stupid things because they do what we tell them to do and not what we meant to tell it to do. Okay, there are basically three kinds of errors. There's the type 1, which are the compile errors. And if your program won't compile, it simply won't run. Now this is different than scripting programs like JavaScript or Python, which will run until they hit an error. Now you say that you may think that that's a good thing. That's actually a bad thing. I have had Python programs that have literally run for a half an hour, and then all of a sudden hit some code that was not correct and just bomb out. The compiler will prevent those kinds of errors because it simply will not let you create an executable version unless everything is absolutely correct. Okay, that's one of the reasons why using a compiled language like Java is preferable in a large program to an interpreted language like JavaScript. Now, just because it runs doesn't mean it's going to run without error. So there are runtime errors that can occur, and you will encounter these. The most common one is something called a null pointer exception. You will get used to seeing null pointer exceptions, and that's all in the future. And then the type 3 errors are the logical errors. In other words, the program runs, but produces incorrect results. So that's something that the best IDE in the world and the best language in the world cannot fix. So that's okay. So the program development, so basically we edit, save the program, compile the program, we try to run it, errors, we kind of keep going back. That's the cycle. And why do we do this? We do this because there's a problem that we want to solve. So, just this morning, what I was programming on was a program for NavSup that helps with their inventory modeling. They are trying to find the optimal levels of allowances for their different parts in order to maximize readiness. And so that was the problem. And so the program that I was writing on that was addressing that. There are some others. So now, in order to do that, I needed to understand what the problem was. I needed to help design a solution. Actually, I was very fortunate in that one of my colleagues actually designed the solution to that, because it was a heuristic that wasn't totally optimal, but it turns out finding the optimal in this case is not practical. But my colleague designed a wonderful solution and actually implemented it in a different language. And I've been implementing it in Java and testing it. So this is basically what we do. The key is breaking it down into manageable pieces. And this is where object-oriented stuff comes in, because with object-oriented design, we break the problem into pieces, and then each object corresponds to what those pieces are. So we break the problem into the different pieces, and those pieces become the classes and objects. Now, Java is arguably a relatively pure object-oriented programming language. Say relatively, it's not 100%, it's 99 and 44, 100% pure. An object is one of the fundamental entities in a Java program, and we can use those to represent real-world entities. So that's a very handy thing. So an object might represent, like an employee or a company. In the program that I was writing, I have objects that represent different parts. I have objects that represent weapon systems. I have objects that represent the weapon systems that are on a particular site or a particular platform. Those are all different objects, and they have things that, so what that allows one to do is say, if I'm interested in a particular weapon system, then I have objects that represent that weapon system in the program. So, and we're going to kind of be going over this, coming back but just for now, the key about objects is that they have states and behaviors. That's so basically a state corresponds with instance variables, and behaviors correspond with methods. So examples might be if I have an object that represents a bank account, then its account number, its current balance, and things like who owns it, and all the other, what type of account it is. So those would all be the different states. Behaviors would include things like, opening the account, make deposits, withdrawals, closing it, and that the behavior might change its state. So if I have an object that represents a bank account and I have a behavior that is a method that says deposit X amount in this, then it changes the state of the balance to increase by the amount that was done there. Things like this can get tricky. So if I have another method that says withdraw a certain amount from the account, then depending on what kind of account it is, then if I don't allow overdrafts, then if I say have $5,000 in the account and I try to withdraw $6,000, then how does the program handle that? Again, things like that are all part of the design. Okay, so now classes though, now what is an object is defined and or so-called instantiated by a class. So the key thing to understand, the difference between an object and a class, and this is something that JavaScript does not do well, but a class is the blueprint of an object, or a template. So the class is where you define your methods to define the behaviors, you define your instance variables to specify the state, and then having defined those, you need to, as a separate task, you can instantiate one or more instances of that class, and that's what becomes the objects. Now, with Hello World, the only object there is that system out, and that's already created for you. And again, as to repeat, the class containing the main method is, when I say represents the entire program. Okay, what did I mean by that? When I say represents, when I say represent, I mean that basically that's where you kind of start. I worded that poorly, but okay. So the class, another way of thinking of it is the class is a concept, and the object represents the embodiment of that concept. So, and that multiple objects can be created from the same class. So if I've defined a class that is, well, in the case of of my program that I was writing, one of the classes that I define is a part. So, since there are literally hundreds of thousands of different types of parts, there can literally be tens or hundreds of thousands of instances of that same part. And within each part, there's there are things like its identification, things like its unit price, its weight, its volume, its relationship to other parts, things like that. In other words, but each part that you create has its own features, and yet there's only one part class that I can literally create hundreds of thousands of different parts from. So again, you can think of it as a blueprint. So you have one blueprint, and you can create different types from that blueprint. If I want a different type of structure for the house, I need a different blueprint. Okay, so again, the concept, the class, the realization is the object. Okay, so and the reason why this is being sort of hammered a little bit is because, at least in part, because JavaScript has this concept of just sort of a prototype object. There's no concept of a class there. Python, to its credit, does have a concept of a class. So Python has, in my view, a bit better object model. Okay, this is something we're going to be circling back to, but and this is something which tends to get a little overused, but in reasonable doses, inheritance can be a very useful thing. It embodies what I call the programmer virtue of laziness, which is having implemented something, you can kind of inherit stuff like that. In other words, you can organize our classes into hierarchies. At this point in time, this is going to be a little vague, so don't worry if this is a little bit not completely clear. All of this will become clear in good time. Okay, so so today we basically had an introduction to Java. See, we've looked at its rules and conventions. We've looked at object-oriented programming, especially the class versus an object type of thing.